All right, folks, it's Bass Action back in action here. We are going to look at our last way of analyzing whether a relation is a function, whether it's one-to-one, and how to find the inverse. And then we're going to algebraically work through an example of finding the inverse. All right, so let's take a look at ordered pairs. These are sometimes actually the hardest ones for students to recognize and how to determine functions one-to-one and then the inverse. So if we want to determine if a set of ordered pairs is a function, all we really need to do is confirm that there are no repeated x values. If we think about graphing this, if there was a repeated x value, that would mean that we would get two different y values and it would fail our vertical line test. So as we work through and look at these examples, if we look at this first set of ordered pairs, what we will see is we do in fact have this x coordinate of 1 in two different ordered pairs. So if we plotted that, it would fail the vertical line test. So our first set of ordered pairs here is not a function, so we can say no, which means that we aren't even going to analyze whether it's one-to-one, and that we don't even need to write its inverse because it's not even a function at all. Moving on to our next set of ordered pairs, we can see that we do not have any repeated x values. So we can say that yes, this is a function. And if we wanted to analyze whether it was one-to-one, what we would look for then is we would look to see whether it had any repeated y values. Because again, if we visualize what would be happening, if it had repeated y values, that would mean that for two different x values, we got the same y value, and it would fail our horizontal line test. So let's look and see if we have any repeated y values. And what we'll see is that sure enough, right here at this y value of 4, oops, meant to do the highlighter there, sorry about that. At our y value of 4, we have the y value of 4 is repeated at two different x values. So we would say that although this is a function, it is not one-to-one. Now, since it is a function, we could actually write its inverse, okay? So we could actually write this inverse, and all that we would need to do is reverse each and every ordered pair. So if we reverse these, we would end up with the ordered pairs of 9, 5. We would get the ordered pair of 4, 6, the ordered pair of 0, 3, the ordered pair of 7, 1, and lastly, the ordered pair of 4, 2. Lastly, we can look at our final one, and we can first look for our repeated x values, and we do not have any repeated x values, so yes, this one is a function. We could look for repeated y values to determine if this function is one-to-one. We do not have any repeated y values, so we could say that yes, this is a one-to-one function. And lastly, we could actually write its inverse because it is a function. We could write the inverse by simply reversing all of those ordered pairs. So we would get the ordered pairs 1, 2, the ordered pairs 6, 5, the ordered pair 0, 7, the ordered pair 2, 8, and the ordered pair -1, 3. Now, the last thing that we're going to do on this page is we are going to actually start finding inverses algebraically as opposed to just working with the graph or a mapping or a set of ordered pairs. So getting into finding this function, this inverse algebraically, what we first want to indicate is how we denote it in our symbolic notation. So a function as its inverse, I'm struggling here today with my highlighter, a function written as its inverse is denoted by this f of -1 of x. Students often want to think of this -1 as a negative exponent. It is not. It is just the notation to indicate that this is the inverse of some function. All right, so let's take a look at our function. We're going to work through our various steps here. So our first step says to take this f of x and write it as a y. It's going to make it easier to work with. So the first thing we're going to do is we're going to write y equals, just rewrite the function as an x plus 1 over our 2x minus 3. Now, thinking about how we found our inverses earlier where we switched our x's and y's, algebraically we're going to do the same thing. So everywhere you see a y, you're going to write an x. Everywhere you see an x, you're going to write a y. So we're going to rewrite this function as x equals y plus 1 and 2y minus 3. Now, the goal is to solve this entire equation for y. So keep that in mind as we work through this problem. We're going to take our left side and we're going to put it over 1 so we can more easily see that this is a proportion. So we're going to cross multiply and we'll end up with x times 2y minus 3 equals y plus 1. Now our goal is to solve for the y's. So what we're going to do is we're going to distribute our x value first here. So we're just going to distribute this x, so we'll get a 2xy minus our 3x equals our y plus 1. And since we're solving for y, we're going to get everything with a y on one side of the equation and everything without a y on the other side of the equation. So we'll have 2xy minus y equals 3x plus 1. Next, we can factor out the y. Now that we have all of our y's on the same side, we can factor that out. It's going to make it easier to isolate it. So I'm going to factor out that y, and I'll have 2x minus 1 equals 3x plus 1. Now that this y is factored out, we can simply divide both sides by this factor, and we will end up with, put it up here, we'll end up with y equals 3x plus 1 all over 2x minus 1. So that's going to be our inverse. And then the last thing that is a nice last step to do is to rewrite the function with our actual function notation to indicate that this new function is an inverse of something that we started with. So we can just rewrite that y now. Instead of the y, we're going to write our f of negative 1 of x equals our 3x plus 1 over our 2x minus 1. And in class, what we're going to do is we're going to actually work with graphing both this function and our original to show what they look like as inverses. All right, that's all that I've got here, and we'll extend this more in class. If you are not one of my students, there should be a link in the description for this video that will take you to a folder so that you could download these notes and follow along if that would be helpful.